Internal rate of return. Internal rate of return is a criterion of investment profitability assessment. It is the maximal cost of capital which the company can accept for a given project without destroying value for shareholders. In other words, internal rate of return is the cost of capital for which net present value is zero. Mathematically, the internal rate of return is the value of R in net present value formula equal to 0. Because in the above situation, cost of capital is equal to internal rate of return, our formula is as follows: primary investment plus sum of present value of future cash flows from period 1 to period n equals 0. In other words, IRR is the discount rate for which the value of future cash flows generated by a given project is equal to initial investment. The relations between internal rate of return, net present value and cost of capital can be presented on following figure. If internal rate of return is higher than cost of capital, the project has a positive net present value. If internal rate of return is lower than cost of capital, then the project has negative net present value. If internal rate of return is equal to cost of capital, the project has net present value equal to 0. Example number 1. Company is considering the investment project with following cash flows. Primary investment of 1,900, cash flow in first period 1,550 and cash flow in second period 1,950. The discount rate, cost of capital, is 10%. Decide if the project is acceptable on the basis of internal rate of return criterion. So knowing that internal rate of return is the discount rate for net present value equal to 0, we can use following formula: primary investment plus present value of cash flow in first period plus present value of cash flow in second period equals 0. So let's insert numbers to our equation. Primary investment of 1,900 with minus, as we treat it as an outflow, plus cash inflow in the first period discounted by internal rate of return, plus cash inflow in second period also discounted by the internal rate of return equals 0. To solve this equation by hand, we substitute 1 plus IRR by x and receive following equation. By multiplying both sides of the above equation by x raised to the power of 2, we receive classical quadratic equation, which we solve with the use of delta formula: b squared minus 4 multiplied by a and c. In our case, a equals minus 1,900, b 1,550 and c 1,950. So our delta equals 17,222,500. As delta is greater than 0, we have two possible solutions: x1, which we solve using following equation, and x2. So we substitute our numbers to the above equations, and our x1 equals minus 0.68 and x2 equals 1.5. Remember that we substitute our 1 plus IRR by x. So, in case of x1, our internal rate of return equals minus 1.68, while in case of x2, our internal rate of return equals 0.5. Because the cost of capital, our nominal interest rate, cannot be negative, we take into consideration only the second result, which is greater than 0. So, IRR for our project is 50%. As our internal rate of return, maximal cost of capital, which the company can accept for a given project without destroying value for shareholders, generating losses, is 50%, which is higher than actual cost of capital, which was 10%, thus we can conclude that net present value for the project is positive and it should be realized. We may solve this example by using Excel's IRR function. Let's have a look. In order to find internal rate of return of this project, we are looking for IRR function in Excel file, where we insert the values of cash flows of the project. In this example, our IRR, maximal cost of capital, which the company can accept for a given project without destroying value for shareholders, is 50%, which is higher than actual cost of capital. Thus, we can conclude that net present value for the project is positive and it should be realized. Example number 2. Company is considering the investment project with following cash flows over 4 periods. The discount rate, cost of capital, is 15%. Decide if the project is acceptable on the basis of internal rate of return. As this example is too difficult to do it by hand, we solve this example with Excel spreadsheet. In order to find internal rate of return of the project, we are looking for IRR function in Excel file, where we insert the values of cash flows. And we receive 13%. Based on this criterion, we have to reject the project as IRR is lower than actual cost of capital, which equals 15%. As the actual cost of capital is higher than internal rate of return, the project will generate losses. It has negative net present value. Example number 3. Companies considering two investment projects, Project A and Project B, with following cash flows over 4 periods. The discount rate, cost of capital, is 18%. Decide which of these two projects is acceptable on the basis of IRR criterion. To solve this example, we use Excel spreadsheet and its IRR function. In order to find internal rate of return of both projects, we need to use IRR function in Excel file, where we insert the values of the cash flows of Project A and the values of cash flows of Project B. For Project A, our IRR equals 35%, while for Project B, 20%. Both projects have positive net present value. However, the positive difference between internal rate of return and cost of capital is higher for Project A than for Project B. In first case, it equals 17%, while in second case, only 2%. Thus, based solely on IRR criterion, we should choose Project A as it is less vulnerable to the possible increases of the actual cost of capital. Thank you.